All right, welcome back, everybody. It's Java time. Okay, continuing our look at objects and classes in Chapter 2. Today we're going to take a deep dive into the methods part of a class and part of objects, I suppose, as well, and really cover all the different elements, all the different aspects, all the different stuff going on with methods. So let's take a look at a simple class called bank account, which is meant to model a bank account. Okay, we've got our instance variables at the top. Looks like a bank account object will store an amount, as in amount in the bank, as well as an interest rate. Next we have our constructor. Okay, and I can tell it's a constructor because the name bank account is the same as the name of the class. And then the rest of this class is made up of 5 different methods. Okay, now what we're going to discuss today is the differences between each of these methods, kind of the different things we can have and do with them, such as the access type, whether it's public or private. Okay, the return type, such as is it a void method, does it return a double? And then also kind of when and how we'd use each of those parts here today. So let's begin with talking about the difference between a constructor and a method. So I have my bank account constructor here. Again, I can tell it's that because of bank account. And then a method, get amount. Okay, notice they're both going to have an access type. Now the really one difference is that a constructor is not going to have a return type, which our methods are. So in this case, we're returning a double, for example. Okay, but they'll both have a name, they'll both have parameters. So really they're more similar than different. We call the constructor sometimes a constructor method. But again, the big way you'll know if you're looking at a constructor or a method is the constructor has the name of the class and then again won't have a return type, whereas all other methods have to have that return type. So let's focus on the methods now. So I have up here 3 different methods from that bank account class: a deposit method, get amount method, calculate interest method. Now every method is going to have a signature. And that's going to be this different stuff: public, void, deposit, parameter list, AA. All the stuff that's kind of gives the information about that method, how it's used, what it's used for, what kind of information we have to pass in. And there's going to be 4 different types to that signature. Now the first type is access. We'll talk about that in a minute, whether it's public or private. The second type is the second part is the return type. Okay, whether it's void and doesn't return anything, or if it return something like a double, an int, a string. Third part's the name, and that'll be what you use to actually call the method. So if I wanted to deposit something, I'll say object.deposit. And then the last thing is the parameter list. We'll have methods with parameters that take in information, such as with deposit, how much do we want to take in, or methods that don't have parameters. Okay, so those are the 4 different parts to each of our method signatures. Let's start by talking about the first thing, our access modifiers. Anything you create within a class for an object is going to be defined as either public or private. Okay, for public, that just means that its members, such as variables, constructors, or methods, members with public access can be accessed or modified inside or outside the class where they're defined. Whereas private, our members with private access can be accessed or modified only inside the class where they're defined. Okay, so in other words, if I call something public, I can use that code, I can use that variable, I can use that method in different classes beside the ones defined in. Whereas if I make it private, I cannot access it from any other classes. Okay, this gets into the idea of data encapsulation. Big fancy word, but it really just means we want to protect our data. In general, what we're always going to do is all instance variables should have private access. So anytime we've seen instance variables so far, and anytime you write your own, make them private. That way other classes can't mess with them, can't change them, can't screw them up really. And then what we'll do to deal with that data with those instance variables is we'll make public constructors and methods to manipulate the private data. Okay, so when I design things that way, I don't give my other classes direct access to my data within a class. Okay, but through constructors, through methods, they will be able to access it. That allows me a real nice way to kind of keep all the data tucked away nicely inside a class and have full control over what other classes can do with my private data. Now, if I flip back to the definition of my bank account class, notice both my instance variables, amount and interest rate, are private, meaning that other classes cannot access this information directly. Okay, but we can set it up through public constructors and then change those values, such as with the public deposit method. We can get the value with the public get amount method. So typically your constructor and methods are all public. Except for in this case, notice I do have one private method. It's a calc interest method. Now the times you'd make a private method is if you have a method that you only want this class to use and it's not intended to be used by other classes. Okay, so I want this class to be able to calculate the interest, and as far as getting the interest, such as adding it or finding the amount, I have public methods to actually see what those values are. Okay, so a lot of times we'll call them private helper methods. They're just a way to kind of break this code or this code into smaller chunks, and again, private because it's not intended to be used by any other classes. Next thing we'll talk about in the method signature is the return type, okay, the second part. And the return type just tells what type of information our method is going to return or produce when it's all said and done. And these could be void, as in it doesn't return anything, or it could have an actual type such as double, int, string. That'll be the end result of that method. So let's start by talking about void methods. Okay, those are methods without a return value. So for example, public void deposit. This method doesn't return anything. It doesn't give anything back. All it does is it changes the amount and then doesn't put anything back into the code. Okay, so void methods cannot be used as expressions. I could not, for example, say int a equals account1 if that was a account variable dot deposit 5. Okay, because this account1 dot deposit 5 isn't equal to anything. It doesn't return anything to that point of the code. And the two reasons we'd use a void method in most cases is for manipulating data. Okay, we call that a mutator. Okay, such as our deposit method. It manipulates the int variable amount, okay, stored by our object. Okay, or a lot of times we'll use those for printing. Okay, so for example, public void print account. This again wouldn't return anything, but it would print to the console to give the user some information. All right, next let's talk about return methods. Methods that actually return something back to the place of the code they're called. So for example, public double get amount, which returns the current value of the amount variable stored in that object. Now notice we have get amount here. A lot of times we'll start the name off with get because another name for our return methods are getters, because that's what we'll use them to do, is actually get the information stored in those private variables. Okay, these are methods that return a value to the code that call the method. So as in wherever the code's called, they're going to put that value into the code. And we'll say the return type is specified before the method name. So as in our signature, public double, okay, meaning that this method is going to return a double. And then the reserved word return is used inside the method to send back the value to the method call. Okay, so we use return to actually end that method and send back whatever we want to send back. And the key here is that the value sent back must match the return type. Okay, so this amount must be a double if my return type's a double. Not going to be a big deal for us right now, but as we start writing our own classes, we need to make sure the two of these match. Then last thing we'll say is that return methods can be used as part of an expression. So for example, I could say double A gets the value of account1 dot get amount. Okay, because the result of account1 dot get amount is going to be this double, whatever that amount is. So then I could assign it to a variable or use it for calculations or print it or do anything with the actual amount. And the last part of the method signature we'll talk about are the parameters. Okay, and they're going to work the exact same way they do with our constructors. What they are is a way for us to specify a data type and to pass a value into that method to be used such as in this case with the deposit method, I pass in a double, and it looks like it's going to add that double to my amount. There's two more definitions where we don't need, but we might use them a little bit. I'm going to say that the formal parameters are the parameters actually in the method signature. Okay, so those are the ones that are defined with type as part of the method signature. And then the actual parameters is going to be the actual number that we pass in. The actual parameters are the parameters in the method call. Okay, so formal are in the signature. Actual are what we use when we actually call that method. So for example, here I could say account1.deposit100. Okay, and this method would take whatever is stored as the amount and add the 100 to it. All right, the last thing we're going to talk about is part that's not necessarily always part of a method signature, but could be added to it. Okay, the word static, such as in our main methods, public, static, void main. Okay, static in general, we'll just say static means one. And we're going to say static is a reserved word used to designate something that belongs to a class. Okay, so we're talking about variables and methods that don't belong to a particular object but belong to the class in a whole. Okay, so all objects will share the same static variables and methods, and then static variables and methods exist even if no object of that class has been instantiated. All right, so let's take a look at this static idea in action. Okay, so I have a simple class, the car class, which stores information about cars, such as its type, its miles, and then notice I have a static variable called numCars here. Then we also have a constructor, a getters for both the type and miles, and then we also have a static method, print numCars. Let's talk about both ways static's being used in this program. Okay, so first off, the static variable, we have private static numCars get 0. Okay, with static variables, typically we set them within the class, not within the constructor. Okay, and notice what my constructor is doing here then is when I create a car, at the end of it, it's going to add 1 to that number of cars. So what I have here is a static variable, numCars, that isn't going to belong to an individual car, but to the entire class as a whole. So essentially what this variable is doing is it's starting at 0, and every time I create a car object, it's going to go up by 1. So I have a variable that's essentially just keeping track of the number of car objects I've created. Okay, again, all instantiations of an object share the same static variable. Okay, so if you looked at numCars for the first car or the 5th car, they'd all be the same. And these variables are great for keeping track of totals. So again, this variable, what it's going to do is keep track of the number of car objects I create. We also have a static method, okay, the public static void print numCars. And all this method is going to do is it's going to print out the string total cars plus the variable numCars. And the reason I'd want a static method like this is, again, that variable numCars isn't attached to a specific car object, it's the class as a whole. Well, in some cases, it would be nice to print information about the class as a whole, not a single car. Okay, the word static before the return type means that the method can be called without an object instantiation. So even with this one, before I create any calls, I could call this method and it would give me a numCars semicolon 0 because 0 car objects have been created. Also, static methods can be called directly on the class name or by a reference. So for example, in my main method, I could call car, as in the car class, .print numCars. And that'll give us this string, total cars plus whatever the numCars is. Or if I have a specific car object, such as car1, I could call car1.print numCars, and I'd get the same result. All right, so let's look at that code in action. Here I have 3 car objects being created. We'll call them car1, car2, car3. So again, each time I create one of those cars, that static variable that belongs to the class is going to tick up by 1. Okay, so it starts at 0 and then goes up by 1 every time I create one. That happens in the constructor. And then if I go class name car.print numCars, I should get that total cars 3. because again, there's been 3 car objects created here. And I can do the same thing by going car1.printNumCars. We should get the same thing. Or car2.printNumCars. We should get the same thing. Should be a lowercase c, a little typo there. Now another use for static methods are using them in the main class or the runner class to simplify things and mainly reduce repeated code. So let's take a look at it here. I've got a runner class with a main method in it. And then outside that main method, I have a public static method here. And what this one's doing is it's taking some of the prompting stuff I'd usually do in the main method, wrapping it up in a separate static method to avoid some repeated code. So for example, a pattern we saw a whole bunch is we'd make a scanner and then we'd do this prompting pattern, prompt for what we want, save it as an int, and then do something with that. Well, here that's what my static method's doing. Now if I want to use a scanner from the main method, I need to pass that in. Okay, so we created scan, we'll pass that in a second. What this is going to do is it's going to prompt give me an int. It's going to store that int using my next int method, okay, with the s, the formal parameter for my method here. And then it's going to return the new int plus 7. That's why this is int plus 7 here. So I've got a chunk of code that I don't want to repeat in my main method a whole bunch. And what I can do then is I can say that int num1 gets my method call int plus 7 with scan, this scanner passed in. That's going to run this code, and then I can print out num plus 7, okay, gives me that num1 that I stored here. Okay, for this simple program, it doesn't make much sense to make that new method, but let's say I want to repeat this prompting pattern a whole bunch of times. Okay, well, it'll be easier to write a static method so that I can just make the method call rather than repeating these 3 lines of code over and over and over again. Okay, so to sum that up, static methods can be used within a runner class to mainly reduce repeated code, but then also abstract away details, kind of taking our larger chunk of code within the main method and breaking it down into smaller chunks, okay, to kind of break that code up and make it more organized. All right, so that's it for our deep dive into the methods part of objects and classes. Okay, so now let's put this stuff to practice, start working on programs, crank out some code, and like usual, if you're getting stuck somewhere, let us know. We'll help you out.